Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at scalar, however you would like to say it, and multiplication. So let's go ahead and get started. So when we're talking about a scalar, we're basically, for our purposes, talking about a constant. And so scalars are commonly associated with vectors. And what they do is that they change the magnitude or the length of the line that the vector produces. So if I had to try to give you an idea of exactly what I'm talking about here, it would go somewhere along these lines. So if I have a vector v and it has the coordinates a and b, and I want to multiply that by k, this is essentially what I'm going to get. I'm going to get the following. So the scalar is k here. That's what the scalar is. This is my constant that I'm going to multiply the components or the pieces of my vector by. And so I'll end up with kv essentially, which is going to be the same as ka kb. So this is what it looks like on a theoretical level. Hard to understand, but basically all that's going to happen is this: if k is greater than 1, so if it's greater than, I guess I should do it like this, 1. If k is greater than 1, then what's going to happen is your vector, the line, the magnitude is going to increase. That's what's going to happen. If k is less than 1, so but still positive, I guess. How can I put this? If k is less than 1 but still greater than 0, then so it's like a fraction, less than 1 and greater than 0. So less than 1, so k is less than 1 and k is greater than 0, something like that. Then what's going to happen is that your line is going to shrink, so it'll be smaller because you're multiplying by a fraction. And of course, lastly, if k is negative, then what's going to happen is that your line will change directions, so it'll just switch like that. So let's go through a couple practical examples here. It always makes more sense when you can see it. So we're given the following. So we have v equals 2, 1. Oops, sorry. 2, 1 like that. And we're going to multiply it by 3 by the following. So we're going to multiply it by 3v like this, minus v and 1/2 v. So here we go. This is what's going to happen. So let's do the first one. 3v. I don't think I have to go through all the steps. So 3 times 2 is 6, and 3 times 1 is 3 times 1 is 3. Not a whole lot to talk about there. So that's the answer for the first one. And then so now when we do minus v, this is the same as multiplying by -1. So this is going to now be -2 and -1, like so. And then for this last one, we multiply by 1/2 v. You can probably tell what's going to happen here. 2 times 1/2 is going to be 1, and then 1/2 times 1 is going to be 1/2. So these are our answers here. So let's see if we can take a look at what these will act like when we graph them. So let's go ahead and go here. So our first one was 6, 3. So we're going to start, of course, from standard position. Let's see here. So we're going to do here, and 6, 3, just like that. That's our first one. So this is when we multiply it by 3. But let me go ahead and do the original one. So this was 6, 3. Let me do now 2, 1. That's the original one. So we're going to start here. 2, 1. So they're right on top of each other basically. And you can see right here that this is 2 units, but the new one is 1, 2, 3, 4, 5, 6 units. It's 3 times longer because we multiplied it by a constant or by the scalar of 3. So now we're going to do negative v. So we multiplied it by negative 1 here, so we got negative 2, negative 1. So again, we just do a different color here. Negative 2, negative 1. Like so, just like that. And so this is exactly the same length as the original one, but it's going in the opposite direction. It's going into the negative rather than going into the positive. And so now we'll look at the last one, 1 times 1/2. So we're going to start again in standard position, just change the color. So we start here. So 1 1/2. This is 1 1 right here. And so 1 1/2. Oh, is it 1/2? So it'll be about right there. Let me check that. Yeah, the y is 1/2. So I hope you can see that. So this little tiny blue guy right here is 1 1/2. You can see how it, oh, whoops, I made a mistake. That's not quite 1 1/2. It should be 1, and then it should be 1/2 like that. Okay, there we go. That's much better. And so again, they're kind of all on top of each other because of the way things were set up. But you can see how we're clearly on 1 on the x-axis and we're at 1/2 on the y-axis. And so this is kind of what it would look like. And you can see that it's basically almost about half the distance of the original vector there that we have. And so this is essentially how you deal with scalar multiplication when you're trying to address vectors. So let me kind of go back and recap what we talked about and then wrap up the video here. So in this video, we talked about scalar multiplication. It's a scalar for our purposes is essentially a constant. And so what you do is that in connection with vectors is that when you multiply vectors by a scalar, it changes the magnitude or the length of the line. And so here's the theoretical aspects of it. I hope this was as clear as possible. When the scalar is greater than 1, the line is going to get longer. When the scalar is less than 1 but greater than 0, the line is going to get shorter. And of course, if the scalar is negative, the line is going to go in the opposite direction. It might get smaller in the opposite direction if it's greater than negative 1 but still less than 0, but it also might get longer. That's the things to keep in mind. And so then on this screen, we solve some basic ones. There's nothing really that complicated about this, just basic mathematics here, basic multiplication, and then I graphed it for visualization purposes. So I hope that this video was useful for you and you were able to understand what we were talking about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.